Hello friends, welcome to our channel. Let's have a look at problem 1726, tuple with same product. In this video, again, I'm going to demonstrate how to use dictionary to solve this problem. So this problem statement is very short. So given an array of positive integers, so here distinct. So this is an important assumption. So we want to return the number of tuples a, b, c, d such that a times b equals c times d. So here, because of the distinction assumption, so all those numbers are different. So if you look at example 1, so actually the product is 12, right? You see essentially all the 4 numbers involved are 2, 6, and 3 and 4. So notice that, so if you look at the symmetry, you will see, so if I have an A, B, and C, D, right? So if A, B times, so assume that A times B equals C times D, then actually I can switch the A and B due to the commutativity of multiplication. So A and B can be switched. So there are 2 options, right? Similarly, C and D can be changed, right? So there are also 2 options. And another thing is that I can change AB with respect to CD as 2 pairs. This is another 2 options, right? So if you use multiplication rule, so each of this number, so let's call it the product is the product, right? So each of the product yields 8 possibilities, right? That's why, here for 12 you have this 8 possibilities. So here you see 16 is this one corresponding to 10, and this one corresponding to 20, right? Therefore, we just need to count the different products, right? Then we just make some computations. So that's basically the overall logic of this problem. So what we want to do, what shall we do here in this video? First, demonstrate the use of dictionary. Second, do some simple math, some simple counting, right? So now let me first get the length of this array nums. So I can initialize a dictionary default dict. So because I'm using counting, so originally I just make count to be 0 default. Then we are going to iterate through this nums length. But here I will not going to go too deep, right? So because the length is bounded above by 1000. So if I use a double for loop for I in range n, so n minus 1, because I'm consider pairs. So for j in range, so I plus 1 and n, right? So then what I'm going to store is the product. So let me write product. The product will be nums I times nums j. You don't need to introduce this variable, but here I introduced it for convenience of demonstrating the idea. So what I want to say is this product, the count will be incremented by 1, because these 2 numbers give this product. So now actually before you go further, so you can print out this d to see what we get. So if you look at example 1, so here the product is 12. So here you just have 1 pair giving you a 6, 1 pair giving you 8. Similarly for 18 and 24. So this will not yield any tuples of length 4. So if you look at 12, so there are 2 pairs, right? So these 2 pairs actually yield 8. That's what we explained for the symmetry. So now if you look at the second example, you count greater than 1. So here you have 10, that is 2. So this is 10, right? Contribute 8 pairs. Not 8 pairs, 8 4 tuples. So similarly for 20, this, right? So how do we got this counting? So this actually is rather straightforward. What you do is this, initialize a result variable. So this counting, and then we are going to iterate over the values for v in the values. So we only consider those for value is greater than 1. Then this v is a number of pairs, right? So then we need to choose 2 out of this v so that we can form 4 tuples. So then basically choose 2 out of v, right? And then each two pairs yield 8 valid 4 tuple. That's the computation. So how do we do this? So we choose 2 out of v. This is nothing but let's see, let me write this little v. It's v times v minus 1 interdivision by 2, right? So now let's do this. So what we want to do is result incremented by, first let's get this number, right? So then we times this number by 8, that's it. So if you do 8 times 2, that will be 4, right? But I'll keep this format so that you can retrieve the logic. And then afterwards, we just need to return the result. So that's the full code actually. So we can first do a test run and then submit and pass all the cases. So here again, we demonstrate the use of dictionary. Actually, if you do lots of practice, you will see if you were able to use the data structures like array, list, set, and dictionary, or some subclasses of dictionaries. So it basically you can solve some problem in a very elegant fashion. So that's what I want to convey. And here, besides coding, so doing correct counting for this problem is also important, right? So with that said, I guess that's about it for the current video. Thank you for watching.